A video for you today about the nature of magnetism. I am Miss Agar.
I'm Mr. Bremmerger.
Alright, let's get started. You guys have probably all seen something like this before.
Familiar sight.
This is a refrigerator full of magnets.
And lots of cool stuff. I'm sure you guys at home will love hanging all your artwork on there that you would create in Mrs. Miller's class, or Mr. Hire for that matter.
Test scores, projects, whatever. Probably haven't spent a lot of time thinking about how those magnets are actually working to hold all of those things up for your family to see, however. After this video, you might begin to do that. So let's get started. We have magnetism, straightforward definition, just the force of attraction of a magnet for another object. That should make sense to you. You've seen a magnet stick onto the refrigerator.
Yeah, that is standard 4th grade science, don't you think?
Yes. As is our second point, all magnets have two ends, and those are called magnetic poles.
You mean like a fishing pole?
Not quite.
Okay.
Let's keep going. Magnetic poles, we have the two ends, and we call them the North Pole and the South Pole. Just the two ends of a magnet.
I've heard that before. North and South Pole. Do we have one of those on Earth? Okay. All right.
The poles are the part of the magnet where it is the strongest, and you'll see that in some of our demonstrations today.
All right, so opposite poles attract or repel?
Here we go. Opposite poles, they are going to attract each other. So here we have the South Pole end, the North Pole end, and those two ends of each of those magnets are going to be attracted to each other. Down here, the same poles, if we line up a South Pole with a South Pole, they are going to repel each other and push apart.
This would be a great diagram to make sure that you had in your notes. So if you haven't copied it down yet, I would definitely do so. So I have a question, which you need to roll to the next slide for me to ask. What happens if you break a magnet in half?
Oh, Mr. B, that's a great question. Here we go. I'm going to give you two options to think about here.
Okay, all right.
We have, in option A, here's your magnet, north, south. We have the same option over here. If we break that magnet in half, what do you think? If my clue down here for you is that one option would be that we get two separate poles. What would that look like?
I don't know yet. I think I have to consider this. I think for a little bit. Can you give me the other option?
In option B, if we break the magnet in half, we could end up with two separate magnets.
That would be pretty cool. You know, that'd be a nice way to make more magnets. But I got to think about it a little bit more, I think. Maybe can we come back to the answer to this a little bit later on?
Yes.
Okay.
Let's do that. All right.
Yeah, let's. There we go. All right.
Here we go. Magnetic fields. As we go through this, keep that question in mind of breaking a magnet in half. Some of this information is going to be helpful in thinking about that. All right, magnetic fields is the magnetic force exerted all around a magnet. This is another great drawing that you could put into your notebook. These are the magnetic field lines. The magnetic fields are going to be strongest at the poles. That is why in the last slide we talked about the magnet is going to be strongest at its poles. This is also the reason that magnets can interact without even touching each other. And we'll see more about that when we do some demonstrations as well. Here, if we put two magnets together and their magnetic fields overlap, that is going to be called a combined field. So, like we talked about at the beginning, if we put two unlike poles together, a north and a south, they are going to be attracted to one another, and you can see the magnetic field lines here showing that. bottom diagram here, we have a north and a north pole, so two like poles, and they are going to repel each other. So you should see that these magnetic field lines are not combining here. They're going to repel and push apart.
Folks, there's a great Paula Abdul song that was written back in my era. And the song's called Opposites Attract. All right, if you haven't ever seen it, YouTube it, you'll love it. Kind of mixes a little real-time, real-life stuff with cartoon. It's awesome. And plus, Paula Abdul's in it, so that's cool. Again, opposites attract. That's one of the key pieces that you're going to keep kind of coming back to over the next few weeks or even the next few months here in science. The idea again of opposites attracting and like forces, or even charges in some cases, repelling.
All right. When we keep thinking about magnets, we need to move from just thinking about the outside and the two ends to what's actually happening on the inside. So most materials that we have around in our daily lives are not magnetic. And inside of the magnet, we have all of these tiny particles, and we call those domains. So what's actually happening inside of here is everything is made up of atoms, and the magnetic fields of each of those atoms are going to be pointing in a certain direction. In most materials that we have, they're pointing in random directions and kind of canceling each other out. And then we end up with just a very weak, undetectable amount of magnetism, so those things don't appear to be magnetic to us. With magnetic materials, all of the domains inside of a magnet are aligned, pointing all in a similar direction, and then we end up with a very strong magnetic effect, and we end up calling these ferromagnetic materials. Ferromagnetic. Probably a word you haven't used much before.
But it's definitely one that you're going to be using a lot coming up. So be sure to not only get the word written down, but also a definition in your own words.
All right, there are a couple ways that we can make magnets. Our first option would be to place the unmagnetized material in a strong magnetic field. The other would be to rub an unmagnetized material with one pole of a strong magnet. Both of these methods are going to allow those little domains to all rotate toward the magnetic field and align the same way to become magnetized. Do you want to show that, Mr. B?
Yeah, I'd love to.
How can we magnetize something?
Okay, I have a really strong magnet here, all right? This material, or this magnet's made out of neodymium, which I never even knew existed until I came in contact with this thing. Now, what we can do here is take a whole bunch of paper clips and we can try and pick them up after creating our own magnet. So by touching this particular paper clip to any one of these, we will find that there is no magnetic properties at all in this presently. The domains are not lined up. So if we take and align the domains using another magnet, we get all those atoms in each of those domains and their electrons spinning in the same direction. We can create some magnetic properties. So now I come back to another paper clip and we are able to hopefully pick it up, which I'm hoping you can see on camera. Oh, we can get a little bit. All right, I tell you what, I will show you this in person, or Ms. Agar will show you this as well. It's really cool. Feel free to come on up whenever you want. Grab one of these neodymium magnets and play around with this concept. It's pretty sweet. All right, question for you.
Yes.
Now that we know how to make some magnets, how do we break them? How do we destroy them?
Great question. Thinking about destroying magnets, we have three options. The first thing you could do is just drop the magnet.
Okay, drop it on the floor, smash it. Okay.
To drop it, yep, pretty hard. Second, we could just hit or strike the magnet really hard on an object, on something.
Mm-hmm.
We can also heat the magnet.
Oh, yeah, that would work. Okay, so how do each of those methods really hurt the magnet or destroy it?
Alright, with our first two options of dropping the magnet or striking it on something really hard, remember those domains?
Okay.
If we knock the domains out of alignment, then it becomes an unmagnetized material. If we heat up the magnet, you guys might remember this if you did some chemistry in 7th grade. If we heat up the magnet, it's going to cause the particles inside to vibrate and move faster and more randomly, and then those domains aren't going to stay aligned here either. So it's all about the domains.
Interesting. Okay. Alright, so should breaking a magnet in half, or let me rephrase that. So breaking a magnet in half doesn't destroy the magnet?
I feel like we've been talking about this.
I think we have, yeah. Let's try and answer it.
Alright,
Okay.
Mr. Bean.
Okay.
2 options.
A little nervous. Okay, we have magnet, north and south pole. Alright, so if we break that in half, am I going to get a piece of metal that is just a north pole and a south pole? I don't know. I'd like to see the other option first. So obviously the second one, we have 2 magnets, or I'm sorry, 1 magnet busted in half. One of the chunks making another magnet, 2 poles. Personally, looking at this one, I'm thinking option B. Am I right? Can we make 2 magnets out of 1 magnet?
Mr. B, you are correct. The correct choice here is option E. If you think about all of those domains lined up on the inside, if we're breaking the magnet in half, all those domains are still going to be lined up pointing in the same direction. So we're still going to have poles. We're still going to have the 2 sides with north and south pole being really strong. So this is not correct. We're here. We have all of those domains lined up. We're just going to end up with 2 separate magnets.
Makes sense to me.
Excellent. Anything else?
You know what? I think I'm okay. I think I'm ready to move on.
All right, if you guys have any other questions or need to talk to us about anything related to magnetism, please feel free to come and see us whenever you get a chance.
Have a good one.